In this video, I'd be talking about method overloading. Considering this the same template we have considered to discuss about overriding. In overloading, the method name should be the same, as well as but the argument list must change that of another method defined within the same class, or another method with the same name from the parent class. Okay, so overload methods let you reuse the same method name in a class. Here are the rules to overload a method. You must change the argument list, so this must be changed from that of an existing one. You can change the return type. That could be changed, and you can change the access modifier. There are no restrictions as in overriding. You can declare new or broader checked exceptions. You can have unchecked exceptions, so there are no some such restrictions as you have in overriding. So if you're overriding a method, make sure that the method name is same, as well as the argument list is different from that of the other existing methods with the same method name. This example, right? So class view has a method do stuff, int y and string s. Now foo is extending. This is not an example of overriding because it doesn't have the same argument list. Now, because there is a change in the argument list and yet the same name, right? And also it's throwing exceptions, that is introducing new exceptions, and this one, it's overriding. I'm sorry, overloading. And this is not an example of overriding. Instead, it's an example of overloading. Now, in this example, UA is pointing to use animals, right? And animal obj is pointing to an animal, and horse obj is pointing to horse. And when you do UA.do stuff animal object, then it would this method would invoke do stuff. So animal obj is of type animal, so this method call would invoke this method because this one type matches, and this method invokes this because horse obj is of type horse. Okay, but say if you had something like this, animal reference to horse, okay, so in these two cases you're invoking the method using a reference of use animals of this class. In this method you're using a reference of animal, right, which points to a horse object. You're using UA.do stuff animal reference to horse, okay, which is of type animal, so using the same instance. Now this one, because animal reference to horse, even though it's pointing to a horse object but is of type animal, this method would invoke so this method would invoke this method rather than this method because it's of type animal. Now what is of type animal? The animal reference to horse is of type animal, even though it's pointing to horse object at runtime, but at compile time the type is what matters, and as a result, again, this is a method which is invoked. Okay, so let's see how polymorphism is related to overloading and overriding. Polymorphism doesn't determine which overloaded version is called, but instead it comes only into play when the decision is about which overridden version of a method is called. Okay, so polymorphism does not help in overloading. It only comes into play in overriding. Okay, um, so in this example, you can see that this eat method is overridden here, whereas this one is overloaded. Okay, so now here are a few examples. These examples are obvious. Let's take a look at this one. Okay. You cannot invoke eat on AB2 or H2. It's of reference type animal. And you're invoking eat on H2 using carrots, which is not allowed, because even though H2 is pointing to a horse reference or a horse instance, you cannot invoke the over or horse classes specific method on H2. You could only invoke the overridden methods, or you can only invoke the methods which are defined in H2 on a horse or on H2. So the compiler still looks at only at the reference and sees the animal doesn't have an eat method that takes a string, so the compiler doesn't care that the actual object might be a horse at runtime. Here are a few differences between overloaded and overridden methods. The arguments in overloaded must change. In overridden they must not change. So it's a really important difference. Return type can change. They can change, except for covariant returns. Exceptions can change, can reduce or eliminate, must not throw new or broader checked exceptions. What about the access? They can change, must not make more restrictive. Invocation, reference type determines which overloaded version is selected. Happens at compile time. The actual method that's invoked is still a virtual method invocation that happens at runtime, but the compiler will already know the signature of the method to be invoked. So at runtime, the argument match will already have been nailed down, just not the class in which the method lives. Whereas in overridden methods, the type of the actual instance on the heap determines which method is selected, and it happens at runtime. So in overloading, the compiler locks the signature of the method to be invoked. In overriding, it decides what instance to be invoked the same signature method on. Let's take a look at reference variable casting. Okay, so your animal is a superclass of dog, and you could do this. This is upcasting because you are going up the hierarchy. This is an instance of dog class which is being casted to, or which is being assigned to animal reference. So on the left side I have animal reference, on the right side I have type dog. So you're assigning a dog type to animal, which is going up the hierarchy. So animal and dog. So dog is being assigned to animal. So dog instance is being assigned to animal reference. So that's upcasting. Okay. If you try to, okay, now you know. Okay, as we already know, you could only invoke methods which are available in animal class on an animal reference. Okay, even if animal reference were to be pointing to a dog instance, so you could only invoke make noise, right? And at runtime, if you have an implementation of, if you have overridden make noise in dog, which you did at runtime, if animal reference were to be pointing to a dog instance, this method would be invoked. But how do you invoke a child specific method using the parent reference? That said, how do you invoke play dead using the reference animal if you know at runtime animal would be pointing to a dog instance? This is how you would do it. So if you try to, okay, so if animal, right, so animal is a reference, um, if it contains if it refers to an object which is an instance of dog, then you won't invoke play dead. But the compiler would complain at this point because play dead is only specific to the dog, the dog class, but animal is of type animal, which doesn't know what play dead is. So in that case, you need to cast explicitly. So this is how you would do it. You need to explicitly cast animal so that you'd get a dog. You can store it in a dog reference, and you could invoke dog specific methods. Okay, so this is called downcasting because what you're doing here is this is of type animal initially, and you're bringing it to you're bringing it down the hierarchy, and that's why it's called casting down or downcast. Okay, you can only do downcast on related classes. So that's it. You can only do, okay, if you do some, okay. Now, in this case, as you can see, animal, dog extends animal, and dog test extends, and there's a dog test, right, which is not part of the hierarchy. Now, what you're trying to do is, right, so what you're trying to do is you have animal pointing to an animal instance, so animal pointing to an animal object, and you try to downcast it, but then it works fine at compile time because of the possibility that animal could also point to a dog class, right? So the compiler would ignore it, thinking that animal, thinking about the possibility that animal could point to a dog class, and it would allow this, right? Now this is allowed because this dog and animal are part of the hierarchy. That's the reason why compiler would allow it in first place. But at runtime it would fail because animal doesn't refer to a dog instance. It actually refers to an animal instance, and you're trying to downcast this animal object to that of a dog object, and which is not allowed. It would give you a ClassCast exception. So you would get a ClassCast exception, right, when you try to do something like this here. That's when the parent reference is pointing to its own object, and you try to downcast it to its child reference. But if you try to do something totally odd, which is this here, now you know animal and string are not part of the same hierarchy. That is, animal and string are part of different hierarchies, and if you try to cast them together, if you try to cast an animal instance to a string type, it would give you a compile time error because they're not part of the same hierarchy. If they're part of the same hierarchy, and if you do a cast which is invalid, something like this, you'd get a ClassCastException. So that's why it is really important that you use instance of operator to check if you're pointing to the right type before you do something like this. So upcasts need to be need not be explicit. So something like this need not be explicit. It could be implicitly done as well. Downcasts, however, should be explicitly stated. In the first case, I have this is fine, okay, because I'm changing the type. But in this case, you're only changing the return type, and this is not a valid example of overloading. This is a valid way of returning. this is fine as long as the casts are implicit, and this is fine as long as the cast is explicitly done.